because that's a lot of connected for little beams.
It's only 2 170cm antenna.
Whereas this one I can see.
Okay,
I can see it going in and
can we find a seat?
Otherwise known as the beacon rig.
We'll get underway.
Showtime, I
You
better
see
get
there's
out of the way.
overclockers placed, the transmitters here, and it's also the digital thing.
Alright.
Well, if you look at it, you'll see that the coax, it should be going into the antenna.
Okay,
It's hanging down. Oh, right.
first of all, this is a bit of a special presentation tonight, so thank you for coming out in the crappy weather. Kevin, it's absolutely, I've got Kevin Johnson, VK4UH, here on the FaceTime, who's actually in Adelaide, but the rest of his club's actually in Brisbane. So, it's absolutely crappy weather down here, Kevin. So it's fantastic that we've got so many in the club rooms, which I think you might be able to see there. And also up in Brisbane, we've got a few comments on the chat from the Brisbane VHF Group and the Radio Society up in Brisbane. So this is a joint presentation that was initiated by them, I think, by Kevin and the Brisbane VHF Group. So, Kevin, would you like to say a few words for the Brisbane Group?
Yeah, thanks, Justin. It's Kevin here, VK4UH, who's unfortunately currently down after having organised or tried to set this up, but actually down in Adelaide. But I know the guys are well set up in Brisbane. So just for a bit of backstory, we had a growing body of interest in trying some optical comms up in Brisbane. And so I approached Rex to see if he would talk to us about that. And of course, since our club meetings are on the same night, the obvious thing was that he could give that presentation to Reast at the same time as to the Brisbane VHF Group. And this is the first time we've actually done a link-up of this sort, even though our club meetings are on the same night. So a bit of a new experiment for us in the Brisbane end. So I'm very grateful to you, Justin, to coordinate this, and to the guys in Brisbane for doing the same. And particularly grateful to Rex, who agreed to talk to us. So I'm in Adelaide, but I'm watching online as well. Thanks very much, everybody, for all the effort that's gone in, and we look forward to hearing what Rex has got to say.
Fantastic. Thanks, Kevin. And I'll just remind people who are online and the Brisbane group, if you've got any questions, please drop them in the chat, and we will relay them to Rex. So yeah. Without further ado, I don't think I have to introduce Rex any more than to introduce him and and call him up. So welcome, Rex.
Thank you, Justin. And g'day to Kevin and the group up in Brisbane. When Kevin talked to me about this, I thought to myself, he said he remembered me giving a talk at Gipstech on light. And he said, can you dig it up again? And I've thought about it, and when I did it, it was actually 14 years ago. And occurred to me that some of the things like LEDs had probably improved in this time. And so I did get some more modern LEDs and lenses and a few up-to-date techniques, and started doing tests with Richard. Fortunately, Richard and I, even though we're not line of sight, we can readily work by scattering light either off aerosols or off clouds. So I'll take you through some of the 14-year-old history first, and then we'll update you with some of the more modern things that are available. So some of the first light communication was done here in Tasmania by Joe 7JG up in Launceston, who was actually using VK3AML's transmitter and receiver, but VK3AML at that time didn't have a call sign, so he needed Joe to register a record with a call sign, and Mike Groff, VK7MJ down here. And I got involved in this because Mike put a note on the broadcast, would anyone be interested in helping out by providing transport for VK3AML, and I volunteered, and that got me sucked into the whole question of light communication. Now they did a two-way contact between Mount Barrow and Mount Wellington, which is line of sight, at 168 kilometres, which and they did that with voice, with direct line of sight. When I got involved in this, I was interested in doing over-horizon stuff, and I started doing over-horizon stuff with Ken out of Orielton. What's Ken Sulman? Yeah. And DY, yes. And some of the later work I did with Joe up north, but one of the improvements that happened about 4 years ago, Joe Taylor produced a mode called FST4, and the advantage of FST4 is it's only got 4 tones, they're spaced very close together, and you can fit them between all of the birdies that you get from street lights and other things that cause you problems. Now Richard and I, initially Richard went up to Mount Wellington, and I was at White Hills up near Launceston, and it was a very easy contact, 15-second periods and minus 14 dB on digital. Richard then went home, and it was still minus 14 dB. And his home location has got a lousy takeoff to the north. But that was 133 kilometres, which as an over-horizon contact was pretty good. Earlier, I had my goal originally was to cross Bass Strait, and there's no way you can do that line of sight. So we had to do that by scattering off clouds, and I did get across Bass Strait, only one way because I only had one transmitter and one receiver. But that was 288 kilometres, and I thought that was a record distance until I found out that in 1894 the US Army, using a heliograph, did a light contact over 295 kilometres. And that's a line of sight, obviously, with a...
During the day?
Yeah, because they had needed the sun to make the heliograph work. That's right. Now, most people say if you're going to do light, you use lasers. And turns out there's a lot of disadvantages with lasers. The beamwidth is so narrow that any small changes in refractive index in the air means you get cancellation and addition, and the signal's fluctuating. And to overcome that, you need a much larger transmitter source and a much larger receiver source. And the only way of doing that is with LEDs, which fortunately makes it a lot easier because the high-powered lasers you'd never be allowed to use anyway. This guy, Clint Turner, VK7MO, he's got a really good website, and if anyone's interested in doing that, any of this, put in his call sign, and he's written up how to do all this.
Excellent website.
Yes. Next. Now, first choice of detector. You can use just for line of sight. You can use just a photodiode, BPW34. They're only about $1.50 each, and you still use as large a lens as you can get. But most people, for line of sight, just use a reading lens, which is A4 size. And that sort of thing works very well as long as it's line of sight. The quantum efficiency of the photodiode is high, the cost is low, but the area is, oh dear, I've done that. The area is quite small, and it's important to have as large an area to pick up as much light as possible. Now, photomultipliers, which Justin knows more about than me, they have very high gains, up to 10 to the 6th. But they're very low quantum efficiency, particularly at red light, although you can buy a photo multiply for red light, but the money is just out of ham radio sort of.
Short arm stick probably.
Justin bought a number of photomultipliers on eBay and for a few $100s each. Or, so, and they can have quite large areas, so that is useful. But the end result is we concluded that photomultipliers weren't in the hunt. Particularly for red light, and red light has much less absorption than blue light in the atmosphere, and so we moved away from the photomultiplier, went to the avalanche photodiodes. They have medium internal gain of about 100. Their quantum efficiency is very high. They are quite expensive, $800 for a large area one, and you need as large an area one as you can get to pick up as much light. And the area is medium. The one I'm using in that box is 1 centimetre square, so. And that's a picture of that receiver there. We'll turn it around a bit later when Justin has a chance to show us a full view to the Brisbane VHF Group. But that's a 400mm square Fresnel lens. There's a rifle scope on the top for aligning it. Next. Now, the question is, should you use red, blue or infrared? And this graph here shows that if you go to blue, the absorption percent is sort of 25%, and it gets down very low at red and infrared. Although, unfortunately, infrared, there's all these water absorption spikes, and you'd have to pick your way in the middle of one of those if you're going to use it for atmospheric. Doesn't matter if you're using it in a fibre optic cable, but the low infrareds are a good compromise. I can't use any further into infrared because my APD sensitivity drops off.
You also can't see infrared.
No, that's not as big a problem as you think.
Okay.
We'll go on to that.
Cool.
Now, Justin and I, by accident, discovered what we called the something for nothing law. And
It's a good law.
and how we discovered this is we had, say, 3 LEDs, and we're transmitting, and we doubled it to 6. Now you'd expect to get 3 dB gain by doubling the power, but we got 6 dB, and the reason for that is these detectors detect a current, and so you double the current, and if you double the current, you actually get 6 dB. The downside is if you halve the number of LEDs, it costs you 6 dB. And if you think about that in terms of distance, even aside from absorption, you'd normally lose 6 dB every time you double the distance, inverse square law, but now becomes 12 dB every time you double the distance. So it's something for nothing if you've got the ability to increase the power, but if you're trying to increase the distance, it works in reverse. Now for line of sight, you can use fairly inexpensive receivers and transmitters and voice. One of these transmitters was Mike 7MJ's, and the other was Justin VK7TW.
In fact, that's the one that was used on Mount Wellington.
Oh, right.
For that
Yeah.
for that contact.
For the 168 kilometre contact. So if you're interested in line of sight, you can actually get into this game quite inexpensively. Now, Justin and I then moved on to. Justin lives in a valley, not really a VHF location or a light location. But we found that we could work each other by reflecting off a block of flats that are out here in Battery Point called Empress Towers. So they kindly made them all white for us.
We made them red.
yeah. But that was still with the small single LEDs and BP and single BPW34. So quite inexpensive. Admittedly, we would have been using digital to get the sensitivity, but there is an option of using something to bounce the signal off if there's a high building or something that helps you.
Did the colour make a difference? The white building, or?
Look, I don't know.
We weren't allowed to strip off the white paint.
Could have been a glass window or something.
It could have been.
Well, that's the view, actually. That's the view that we were looking at. So there were quite a number of windows in that side of the building. Did it make any difference? Who knows?
Yeah, we were just pleased that anything worked.
And how long ago was that?
That would be probably 16 years ago.
Crikey.
2006 or 7 or 8 or something.
Yeah.
Okay.
Did we get complaints from Empress Towers? We don't know. And in hindsight, it would have looked like a bright red light, little red light.
Two bright red lights.
That's it. So
And it was the last thing they ever saw.
yeah,
Yeah, no, any retina damage?
Science experiment.
Briggs, I'll just make a comment here. We've got the Brisbane Group online. We've also got Peter Young online from Victoria. We've got Paul Pross from Scotland.
Oh, wow.
Who's looking in.
G'day, Paul.
We've got Andrew Elwell from Western Australia, and we've got Ken from New Zealand.
Oh, wow.
So yeah. So we've got a global audience.
Excellent. Okay. Now, over the horizon, the only way you can get round the horizon is to scatter off something. And this sort of takes us back to, you know, in the 1930s, no one thought VHF could go other than line of sight. And then Ross Hull did his experiments and found troposcatter. Sometime after the war, people found out that you could do microwaves with troposcatter, the dew-line system that the Americans used. And you can now communicate over the horizon with light. You can use photodiode arrays by making up a matrix of, we made up a matrix of, I think, 5 by 7 for little BPW34s. Trouble is, there's a lot of dead area around their sensitive areas, the BPW34s, and you can't put them in zero space. But that did work. And with the multiple diode arrays, we could actually get voice up to about 20 kilometres. And then by going up to the APD with its gain and its much larger area and no dead space in the middle of it, we got up to over 250 kilometres using cirrus clouds, which are high enough. They're sort of 7 kilometres up to 10 kilometres, which allows you to work potentially up to about 500 kilometres.
Is the launch angle important? The incident angle into...
we'll cover that in a bit further down, but probably the right answer is to say, I don't know. There's a lot of things we don't understand, and I think that's part of the joy of this, that there's a lot to learn. Now, some of the initial over-the-horizon stuff I did with Joe Gelston. This was a 60 Luxion 3 LEDs. Luxions were the only available LEDs at the time. They were pretty good, but not as good as what's now available. We just used 20mm lenses on them. And this is Joe at Mount Horror beaming out to me at Stanley, and that was 210 kilometres, and a fairly easy contact with JT65A. We ultimately decided, well, my personal goal was to try and cross Bass Strait, and Joe went to Mount Horror, and I initially went to a place called Mount Fatigue, and I thought going from Mount Fatigue to Mount Horror sounded pretty appropriate.
Captain Cook.
Well, it's interesting you say Captain Cook, because Mount Fatigue was actually named by the Beagle expedition that Charles Darwin was on. It turned out when I was beaming towards Joe, I'd set up in the daylight and got my bearings all right, and as night came, I found I was beaming right over Port Welshpool, which is where the ships service all the Bass Strait oil and gas platforms, and they run these really bright lights all night for these ships. So I had to move down to a place called Mount Liptrap. I don't know whether the Beagles named Mount Liptrap, but it's hardly a mountain, but at least it was, you could see just over the water, so there was no chance of any lights, perhaps occasional ship getting in the way. And this was that receiver on the top of my car. And you can see there's high cirrus clouds. The problem is you really got to work out, is it the clouds that are halfway between us, right on the horizon, or somewhere higher up, and where are you going to be? Now, initially, once it got dark, I had Joe just sending a single tone. And I could see the single tone, and I was sort of reporting to Joe, but I said, look, it's not strong enough to try a communication at the moment, but I can just see a single tone. And Joe's one of these people who, he doesn't have a lot of patience. He's a real enthusiast. And he's saying, oh, I want to beam up, I want to do this. So I said, look, we've got a signal at the moment, I don't want to lose it. If the clouds come good, we might actually cross Bass Strait. And after about an hour, Joe rings me again, I want to beam up. All right. And immediately we picked up about 20 dB, and we'd obviously picked the right elevation to beam.
So beam up, you meant?
In elevation. Yeah, we're pretty sure we can get the azimuth right, but it's much harder to know which clouds at what height.
And Rex, there was a bit of a story, and the reason Joe was probably chafing at the bit, because the two times before we were fogged in.
And he was worried about the fog coming in.
Yeah.
Yes.
As soon as the sun went down, the fog rolled in 2 nights before, and we just went, that's it. Fog's number one attenuation.
So
Yeah.
for that distance, Rex, what elevation, for that distance, what elevation were you running?
Look, initially I thought I was running just above the horizon,
Yeah.
and I forget how much further I beamed up, but maybe 5 degrees. I'm not sure. Yeah.
Interesting to know what height the two beams would have intersected at.
Yeah.
You didn't work out those.
I mean, there's so many interesting things that at the time we were focused just on crossing Bass Strait, and once we'd done that, we thought we'd done what we wanted to do, but so many more interesting things you could do now that we understand a bit more about it.
Now, there is a comment here, Rex, from Surge. Get an aviation weather forecast for cloud heights. Now, there was a bit of analysis that went on.
There was, yes. Fortunately, at that time, Launceston had their own, what Launceston thought was their own forecaster. He was actually a public relations guy with an arts degree, but the problem is Launceston is in the electorate of Bass, and the Bureau of Met didn't really want to run a forecasting office in Launceston, but they got told that to keep this going. I doubt if he's still there. Brendan, I think was his name, but he was very good. He had access to all these computer models and gave us information about when there'd be cirrus cloud and no lower cloud, because if it's lower cloud you don't get to the cirrus cloud. And that all worked out pretty well. Any others? No. Yep.
Got a few more online.
Now, at that stage, my view was I wanted as strong a signal as I possibly could get, and what I did was added not only 63 watt LEDs, but put these little Fresnel lenses on each one. The problem is I then only had 2.2 degrees beam width. And if you're trying to beam something, I mean, even us that's involved in EME, keeping something on the moon within 2 degrees is an achievement. And in this case, you can never see anything that you're trying to beam at. So keeping it within 2 degrees and 1.8 degrees at the receive end is the beam width of the receiver, is almost impossible. And I just wonder how much luck was involved in getting across Bass Strait. Now, of course, I had 60 LEDs with their own lenses, and I had to have them all lined up, pointing in parallel. And so I made up a grid in the bottom of my garage, and the grid was the same distance apart as each of the Fresnel lenses. And I shone them on the grid, and I mounted the LEDs on little heat sinks with oversized holes so I could move them slightly and adjust them all so they were exactly on that grid, and so all the energy was going in the same spot. And we then did a test with this here at the club one night, and I think we were probably pointing up 30 or 40 degrees at quite high elevations at the clouds, and you could see there's almost a perfect round spot where all of these were aligned. What you can also see is scatter from aerosols on the way up to the cloud. It's obviously much weaker, but you can actually, we have found there is a significant advantage in using aerosols, and we'll go on to that in a minute. But just remember that picture when we talk about aerosols.
Need the Batman logo.
Now this is Joe transmitting at Mount Horror, and you can see all these separate LEDs converging to the same spot somewhere out there. Unfortunately, in order to align this, we had a rifle scope on the transmitter as well, and Joe had aligned it on the town of Bridport, and he was waiting for it to get dark, and he transmitted while he was still pointing at Bridport, and somebody in Bridport thought there was a bushfire up on Mount Horror. And they rang the police, and the police thought bushfire, we'll get onto forestry, and forestry rang their local guy who looked after the forests up in that area, and he started trying to track this down. Now, in the forest areas, there's just little tracks through the forest, and you're going the hills and valleys. So this poor guy, half the time, he couldn't see where this bushfire was coming from. As well as that, we were using JT 65 at that stage. It was turning on and off every minute, making it even more difficult for this guy to receive or to find it. Anyway, Joe noticed some lights coming up the road, and he thought, oh, some yobbos, I'm a bit worried about this, so he turned it off, and the car came up and it stopped well away from him, and neither of them knew what the hell to do because the guy couldn't find the lights, Anyway, Joe plucked up courage, walked down and had a chat to him and explained what was going on. And the guy was quite nice. He said, look, if you're doing this again, here's my number, let me know. So,
wasn't getting paid overtime.
yeah, well, he might have, but I don't know. It did sort of warn me that using high power red lights just does attract a lot of attention. I mean, even when I was doing tests from my house in Hobart, I'd get reports from hams who'd say, oh, I saw your red light going across the bridge. Justin will tell another story.
Oh, well, that was the red and blue test. That was
right.
The red and blue test. Unbeknownst to us, there was a terrorist exercise going on.
And sorry, I'm going to walk up here because we've had a report that it's not very loud. Terrorist exercise going on. We didn't know that. Rex was at Coles Bay. I was at Rex's house, and we had a red and blue. Actually, it was only a Luxian in a PVC tube. That was all it was. Pointed at Coles Bay. Now the problem with pointing at Coles Bay from Rex's place is it goes straight over Hobart Port Control Tower, which is where the terrorist exercise control centre was.
Oh no.
And of course they didn't know they didn't know what was going on and what was the thing that was the terrorist activity. And so this red and blue flashing light comes up the hill to Tolman's Hill, drives in the drive. These two young coppers get out, ask a whole lot of questions, and I just answered them or whatever else. Actually showed them whatever else, and I watched one of them write science experiment in their little notebook, and I went, and they disappeared. But anyway, that was.
We probably we will talk later that to avoid the problems of bushfires and red lights, we're thinking of going to more towards infrared, which probably would be even worse for the terrorist exercise because they had infrared detectors around the port. Right. Now, once we've beamed up, if you look at this diagram, or it's actually a spectrum display from Spectrum Lab, and you can see there's some spikes down the middle, some white lines down the middle, and some across here. Now, the way we were transmitting information was we broke call signs up split them in half, and if you look at all the combinations for half a call sign, there's 18,000 of them. So we had to send 18,000 different tones for half a call sign, another 18,000 for this half. And these 18,000, to fit them in, they were only 3 millihertz wide. And they started at 1,000 hertz, and VK7 starts here, so because both of us were VK7s, the VK7 is the same frequency. He was 7JG and I was 7MO, and you'll see there's a slight difference in frequency. And then to actually send a signal report, we sent that below 1,000 hertz. So if you knew where the signal was coming, you knew whether you were getting the first half of call sign or the second half, and a signal report. Because we only did it one way, we weren't transmitting a signal report, but potentially this method was the best we could go. It took half an hour to transmit, well, not quite half an hour, to transmit 2 call signs and a report. Yeah. And this program, which was written to us by David VK3H, written for us by David VK3HZ, decoded what those tones actually meant, spaced 3 millihertz apart. And you can see here it was decoding quite well, VK7, and then when I switched to the second half of the call sign, VK7MO, that hash meant there was no third letter. Whatever you call that. Tilde, okay. And it was actually working quite well. Now I'll just go back. If you look at the actual spectrum display, you can see the spike up there, and those, they are 10 dB, so there's almost 20 dB out of the noise once we beamed up after Joe pressed me to beam up. The problem with running sound cards at 3 millihertz is we had to GPS lock the sound cards. They're not accurate enough to run exactly at 3 millihertz, but we did that. Now,
special external sound cards, or
yes, it turned out that you could get an external sound card that worked from a 12 meg crystal, and to GPS lock it, I had to get 10 megs, divide by 5 and multiply by 6 and lock it with that. Yeah. Now, recent developments since we crossed back straight. Joe Taylor has produced a mode called FST4, which we now use in place of weak signal communicator. It's got a number of advantages, which we'll go into shortly. There are certainly better LEDs and lenses available. Potentially you could go up to a larger Fresnel lens. I've got a 1 metre square Fresnel lens, and Justin has one too.
Scary lens.
Yeah.
When the sun's out.
Well, we did a test at, we went to Ken Sulman's men's club out at Orielton, and we thought with this 1 metre square lens, we might be able to boil a bowl of water. And so someone got us a bowl of water, it was a stainless steel bowl, and it didn't do much good. The water's just got so much thermal inertia and bubbled a bit, but we couldn't boil the water. But we slipped off the side of the water onto the stainless steel bowl and almost instantly burned it right through.
A hole in it.
A hole in it.
Wow. It then started to track.
So, yes, you've got to be careful with these lenses. I mean, experiments I've been doing with Richard, I have to cover it up every morning because if the sun gets through, it's a wooden box, I could easily have a bushfire, a house fire. We've been doing work on propagation with Richard, both cloud bounce, rain scatter and aerosol scatter, which we'll talk about. And finally, there's the question of avoiding public concerns by going to 730 nanometers compared to 630, which we were using at the time. Now, FST4, I just compared it here with Q65. It's not quite as good. Q65's got sort of 1 to 3 dB advantage depending on how many seconds you spend transmitting a message. But FST4 can actually go right up to 1800, which is half an hour to send 2 call signs and a report. and get you down to minus 43 dB on the WSGG scale. So the only reason you're going to want to get the last few dB that you could get with Q65 is if you're in a situation where signals are so weak, in which case you'd go to the 900 or 18 anyway. So I don't think there's any real advantage in Q65. And the other advantage is Q65 has, because it's got 65 tones, it's spread over a much wider bandwidth than 4 tones, and you can therefore you've got the problem of QRM from city lights, and they come out at either 50 hertz or 60 hertz or harmonics or thereof. And now you can certainly fit FST4 within those harmonics, but probably not Q65. So our view is that that FST4 is now the way to go. Compared to Weak Signal Communicator, which was the program we used to cross Bass Strait, which David 38Z wrote, it takes about 30 minutes to send 2 call signs and report. FST4 works to minus 43 dB. I don't have measured results comparing them, but my best estimate is that I don't know where I've got a 5 there. It's FST4, but that FST4 is probably about 5 dB more sensitive than WSC, Weak Signal Communicator. So that's the way to go. Because you can feed it between the birdies, it doesn't suffer false decodes from birdies. And it has very narrow occupied bandwidth, 0.36 of a hertz in 30 minutes, and even in 5-minute periods, which is what Richard and I generally use, it's only 2.2 hertz wide, so very narrow. It's got excellent forward error correction. You sort of have forward error correction when you're using WSC because you actually know what the call sign is at the other end transmitting.
So you've got AP on?
Yes, in your head. But knowing that you've got a program that's doing it right, and the other advantage of SST4, if the signal's better, you can actually run it in 15, all those right up to 18, from 15 seconds right up to 1800 second periods, and complete QSOs more quickly.
Is that GPS locked? You're still...
I don't have to be, you don't have to be GPS locked.
Oh, okay. Well, that's advantageous.
Because it's even at 1800 hertz, that's 4 tones spread over 0.36 of a hertz, which is about 0.1 of a hertz tone spacing, which is still much wider than 3 millihertz tone spacing. Not 0.3, 3 millihertz, so it's 3 versus 100 millihertz. Most sound cards are okay for that. I do put my use a good quality external sound card, and I put it in a foam box.
Thermal insulation.
Yes. Now, the big advantage of FST4 is you can fit it between birdies. Now, what we're doing here is Richard's actually got 2 transmitters running, and we're comparing the results. And you can see here we're using the 47mm lens lower, which is the lower of those, and the Fresnel lens, which is what this used to be, and comparing the two, and we put one on 6, well in this case it was on about 680 hertz, and this one on 640 hertz. All these birdies tend to be, you can see a wobbly birdie there and a wobbly birdie here. The wobbly birdies are always multiples of 50 hertz, and that's because the hydro can't keep their frequency stable. I mean, this is at 1800 hertz is the umpteenth harmonic, and it's probably only moving 1 hertz, which means at 50 hertz it's not moving very much. The ones that are nice and stable are usually multiples of 60 hertz, and that's caused by the fact that a lot of these big display signs that you see are run at 60 hertz, and Richard was able to sit outside a display sign next to the Brooker Inn, and he could tell me when the picture changed, and I could see the difference in the strength of the signal. Now, one of the nice things about FST4, if you look right up here, there's a little green marker there, and also a green bar. Now, the upper and lower green markers define where it's actually going to look for a signal. And so you can have birdies out here that are not that important because it's not looking there. The green bar defines where it first looks. And so if you've got the green bar above this one, the order of things will stay the same. It will always find that one first and then give you the next one. The space in between represents, because it's only transmitting 5 minutes on, 5 minutes off. Now there is actually a birdie here at 680 hertz, which 1680 hertz, which is some multiple of 60 hertz. And we actually later moved this one down to 1660 to get away from that. Now, using FST4 and transmitting from White Hills to near Launceston to Richard, this is what the path profile looks like.
Who lives in a hole?
Richard. And this is the test we did just after we went from Mount Wellington to White Hills. So with a good takeoff from Mount Wellington, we were getting sort of minus 14 dB signals. And Richard went home and we tried it again. It was still about the same over just a slightly shorter distance, despite the takeoff being dreadful. Whether conditions changed or not, we don't know.
Does that take into account the curve of the Earth, that profile?
No. No. Now, to test things, yes. we set up this device here, which is a whole set of 3 LEDs of different types. Why we use 3 is the LEDs basically have a voltage drop of about 3 volts. So if you're running off about 12 volts, you can run 3 in series and just trim the power supply to get the current to what you want. And so we'd run all these at 1 amp average, which is 2 amps P, and compare the different LEDs, the modern ones and the old ones that we previously used. And we measured the output with Justin's photometer, which is this thing, and that measures actual power in microwatts per square centimetre or per something. I'm not sure how it does that, but I have to assume that it knows that it's measuring power rather than the current, like the APD. Maybe it's got a modified APD that corrects for it. Now, what I'm going to do now is compare the light. Now, that's the old LEDs, which are at 630 nanometers, and that's within the visible light. We then change that I have to just adjust the current to the same current. And that's the new LEDs, which is at 730 nanometers, and you can hardly see them. However, they are at least about 12 dB stronger when you receive it than the bright one.
Due to path loss.
No, just your eyesight is so much more sensitive at 630 nanometers than it is at 730 nanometers.
Yeah, but you're not receiving it with your eyes, you're receiving it with the photodiode.
Oh, that's right. Yes. But when you look at that on the wall, you're using your eyes.
Yeah, okay.
Yeah.
So why is it 12 dB hotter?
Just more modern lens. Modern LED and lens combination. We'll go on to that next. Now, here is measured with Justin's photometer, changing the current. This is the peak current that is plotted there, from 1 amp up to about 2.8 amps. You can see they do level off at high current. That's their specified maximum there. You can certainly run them well over their specified maximum. All that happens is, instead of getting 10,000 hours out of a lead, you might only get 1,000 hours. But you can certainly run them at several amps more than that without actually burning them out like a fuse. But you don't actually gain all that much. You know, if you go to the maximum specified, you know, you go from there to there, about 0.6 of a dB. Now this is 0.6 of a dB in optical intensity or power. So this 6 dB improvement over the old ones is actually 12 dB in detection with the APD. And that's a dramatic increase to pick up 12 dB with a more modern lens. Now part of that is the lead itself, and part of it is the lens. They're both the same size physical lenses, both 20mm, but the modern one has a beam width of about 8 degrees compared to the older one at 10, which focuses the energy. Interestingly enough, there is about a dB difference between a modern 660 and a modern 730. I'm not sure that that's necessarily real, because there are variations from lead to lead even out of the same batch. but it certainly looks like you don't lose much by going up to 730, and you certainly reduce the intensity to someone's eyes and the risk that someone will think there's a bushfire.
So, Rex, that light we saw on the wall, was that being pulsed? Or
It was being pulsed,
being pulsed, yeah.
but it was being pulsed at about 1500 hertz, and you wouldn't pick that up.
Rex, we were using Cree leads underwater for video filming, and still we had the water for getting rid of the heat, and we had massive heat sink in behind them. How did you go getting rid of the heat on your leads?
Look at that heat sink.
Oh, right. I can see, okay.
And there's a fan on the end of it.
Okay, right, okay.
At no point did it ever get hot.
No. I don't think I don't think you're doing the heat sinking for the purpose of stopping failure of the leads. Leads are more efficient if you can get them cool. So you need to have a heat sink and a fan on it to make them as efficient as possible. Now, an improved LED is over the 20mm lenses there. I'll hand round some 20mm lenses and some 47mm lenses. That's a 20mm lens. And there's some 660 and some 730 nanometer LEDs, as well as some of the old original Crees which look black. And you can pass those around, get a feel for. And most of the testing I've done with Richard have been with these. We've got a hinge on the top bay, so we can tilt the top bay up at a different angle and compare the results between the two. Run one at say 1640 and one at 1660 hertz and compare them. Now this is a test box, and you could see an example of this. And the idea of this is you can flip that Fresnel lens out of the way and just measure the power that you're getting from the LED on its own with its own lens, and flip it upwards, and we can measure the difference. Now, the difference when you flip the lenses is we use the without the Fresnel lens, we use that as a reference, and that's 0 dB up to 14 dB with the Fresnel lens when you measure it with Justin's photometer, and effectively you've got to double that in terms of detection with an APD. So the difference is actually 0 to 28 dB. So having the lenses makes a big difference, focusing all the energy, but it has downsides in as much as you've got to point at a moving target more accurately. And but if you look at the different ones, the new Cree lens at 1660 nanometers, and the new one at 40 at 730 with a 20mm lens, or at the same one with a 47mm lens, the gain over this on its own goes up from 12, 14, 20 dB, and this is almost, well, it's still not as good as with the Fresnel lenses, but it's a lot smaller area once you're trying to build something with 60 of them. Now the strange thing that happened is when we compared the difference in the power with Justin's photometer going from 0 to 28 dB by flipping that and comparing it with what we actually got in practice, it was only 13 dB difference. And the reason for that, I think, took me a long time to work out why, is that if you're using aerosols to scatter off and you've got a wider beam width lens, you actually can pick up all the scatter from all the aerosols from here right up to the yellow. But if you've got a narrow beam width lens, you can only pick up the aerosols in part of it. Now, because you've got a much narrower beam width and more gain, there is an advantage, but you don't get the 28 dB you thought you were going to get. You only get about 13. It's potentially possible to use a larger 1 metre lens, and in theory that would increase the area that's capturing signal by a factor of 6.25 and the detected signal by 16 dB. Now, there are some qualifications to that. Is the noise will also increase, but if you're going across Bass Strait and it's absolutely dark, as opposed to where I'm working Richard across the northern suburbs of Hobart, you might not get the advantage that you would be if it's dark, where you could potentially pick up 16 dB with the larger lens. As well as that, much of the noise is probably not coherent, and so it probably doesn't increase at the same rate as the signal, which is coherent. Now, in terms of propagation, the tests we've been doing with Richard have shown that a lot of the time we get aerosols, some of the time we get cloud scatter, and it very much depends on the sort of clouds that are involved. For instance, if you've got stratus clouds below 2,500 metres, they have a tendency to have fairly flat bottoms between 10 metres and 100 metres. You've got stratocumulus, they have wavy bottoms like 50 to 100 metres, and I'll just show you a little demonstration. Here's my wavy clouds.
Can we do it over here?
Yes. Now, if I had a cloud with a flat bottom, I would get all that energy that I can see there. But if I've got a wavy cloud at a low angle, I'm only just getting energy off the tops of the clouds.
The bottoms.
Pardon?
The bottoms.
The bottoms, yes. Yes, sorry. Now, when you go up to high-level clouds like cirrus, they're actually not nearly as dense as the low-level clouds, and they act more like aerosols, where you actually get scattering from within the cloud, and so you don't get that same problem. Rain scatter, we think, has happened at times, but we're never quite sure whether it's rain scatter. The noise from the northern suburbs of Hobart certainly increases if the clouds drop down, because they then scatter the noise within my beam width, and if there's fog or solid rain, it's complete absorption. Now we'll run through a few of the tests that Richard and I have been doing. Here are the common sort of clouds for Tasmania. The stratocumulus are the ones with variable bottoms. The stratus, fairly even clouds, and the high cirrus. So aerosol scatter is basic aerosols that sort of dust and salt particles and things in the atmosphere. And they produce a very consistent signal. You don't get much variability. Cloud scatter is stronger, possibly 10 to 20 dB stronger, but it's very difficult to get both ends aligned properly for cloud scatter. The consistency of aerosol scatter makes it possible to use very long TX periods, up to 30 minutes, and get sensitivity on the WSJT scale down to minus 43 dB. Now, this is aerosols and rain or cloud. At the moment I'm not absolutely sure, but I'm sure that this is aerosols. You can see how consistent it is. The signal strength doesn't vary much, and when it does, it only varies by 1 dB, which is the smallest increment you can measure in WSJT. The reason it drops off at this end is when the sun starts to come up. And then every now and again there's these stronger signals. And when I look at the cloud height, there's no correlation between these stronger bursts and the cloud. Admittedly, I can only get the cloud height from Hobart Airport, which is a fair way away from the direct path between Richard and I, or about 18 kilometres. And it turned out there was 9.6 millimetres of rain reported over this evening. So I'm pretty sure these were little rain showers that were scattering some stronger signals.
The question, can you elaborate on the coherence of the light, i.e. the difference between the desired signal and the noise?
Yeah, we'll do that next.
Okay, cool.
Yeah. Well, not quite next. Okay. Here's another advantage, an example where you can see the aerosol. It's changing, but only changing very gradually. It's quite consistent. And then at the end, this is this is cloud, because there was no rain reported on this day, and yet there were just occasional bits up here which are probably cloud. And I think next, this is where we can sort of answer that question, Justin, or whoever it was. We can use Spectrum Lab. Well, first of all, we can just plot signal to noise as it comes out of WSJT, and that's what it looked like on this night. But when you actually look at the noise is varying, and the signal is varying, and the end result of signal and noise varying is a change in signal to noise. And what I think is happening here is, as the cloud gets lower, it scatters the lights of North Hobart more, and the noise increases, and it also reduces the area above Mount Direction where we can pick up the scattered signal. And so you start to drop the actual signal level, and increase the noise level, and that's why you get a drop off in signal to noise. Now this method of using Spectrum Lab, I think is very informative, because Rich and I can run this the whole night. Spectrum Lab has a plotter equivalent to an old-fashioned chart recorder, and you can slow it right down to have a whole evening. In this case, here's the sun's just going down. When the sun hasn't gone down at all, it seems to saturate and you get nothing. And then as the sun gets weaker and dusk, the noise starts to go right down, and all of this is noise scattered from clouds. So it gives you an ability to visually see what happens at the whole night. You don't have to sit there for the whole night watching it. You can get up in the morning and say, I wonder what all that meant. But there's a lot to learn from these sort of charts. Here's a low cloud day, and you can see where the noise is increased before the signal has substantially dropped off. And what I think's happened here is the cloud has come in halfway between us, and then it's dropped off and cut off the signal almost completely above Mount Direction. This is where we've done an experiment using both of these, with one of them tilted up about another 7 degrees above the bottom one, to see whether the top one might scatter more effectively off the cloud. Occasionally, the top one is the blue. Occasionally it just got up to the same as the red, but most of the time the red was generally in front. On Aerosols, there's about 5 dB difference between the higher one and the lower one. And when the fog came in, well, there must have been a little bit of a break in the fog, but other than that, it just about killed it. Here's another example of cloud. In this case, I've plotted the cloud from the airport, and the cloud did drop here at the same time as the signal dropped and the noise rose, so I'm pretty sure this is an example of low cloud cutting off the signal. It'd be nice to have the airport right in the middle of the path, but the data from the airport's centimetre. Now,
Shooting lasers across the airport is probably not.
It's not lasers, it's only LEDs. Yeah. Well, it'd be nice to have some data on the path. Yeah, perhaps not the airport.
Weather station rather than.
Yeah. In this case, what I did is I wondered what the beam width. I calculated the beam width at 1.8 degrees, and here I have actually used Spectrum Lab at a fairly fast pace to see what happens as I beamed plus or minus 1.5 degrees to get off both sides of the beam width. And you can see the signal strength crashed by about 10 dB. So you've got to be lined up pretty well spot on for it to work.
Rex,
Yeah.
you talk about having to be lined up so well, but then you're also talking about aerosol, like using the aerosols.
in the air
Yes.
to reflect off of or refract off of. So I'm surprised that you're not that the air, even if you're a little bit off, there's not enough refraction to.
Yeah,
carry
I
the
think
light.
that that case where I talked about lined up was off clouds.
Okay.
Yeah. Now, in terms of aerosols, Andrew Klaverchuk, when I started discussing with Andrew about what I was doing, he says, "Oh, I've got an instrument measuring aerosols in my backyard," which most people would have. And so, and I put all the data on the web.
Rex, you might want to explain for Brisbane who Andrew is, because I'm not sure.
Okay, yes, and Andrew is very interested in ham radio, and he said he's going to get a course on soon. But he's a physicist who works at the Australian Antarctic Division, and he started off as an auroral physicist and finished up as a climate physicist, and he's about to retire. He keeps saying that, so I don't know when it's going to happen. But he seemed very confident tonight.
Cool sign company.
Yes. The only problem is, when you look at the aerosols were weakest when the signals were strongest. And I think the problem is, the signals are strongest because that's cloud scatter and this is aerosol scatter. And so it's very hard to disentangle the signal strength from the measured aerosols. Now, we've explained the problem about public concerns about bright lights, and for that reason, I'm fairly keen on moving to the 730 nanometer wavelength, which, as you saw, is visibly much weaker because your eyes don't respond that well to it. Unfortunately, the large area APD does drop off in sensitivity as you go up, but that in detectable sensitivity, that's only about 2 dB, and you can make up 2 dB by putting about 15% more LEDs. So if you want to have 730 instead of having 60 LEDs in the array, you might want 75, or not even that much, 70. And I think that's the way we'll probably go in the future. Eye safety, because 730 nanometers your eyes don't respond well to it, you won't blink like you would if a bright light at 660 was there. And there are concerns about using particularly infrared lasers, which people can't see, and that in terms of eye safety. I haven't got a complete answer to this, but the research on the web suggests that lasers are just so extremely narrow in beam width that most of the problem is caused by burning out part of your eye, whereas with with LEDs, your beam width is spread over the full dimension of the lens for a start. The data on the lens, one supplier said that a high power infrared, he claims they are safe at 1.6 meters for 6 minutes. So they don't seem all that bad. I can't get any data on 730 nanometers, but I think the answer is just position this. If you're using them at 730, position it where no one can walk closely in front of it, and certainly at the moment where we're using only 3 LEDs, I don't think there's a problem at all. In fact, at Richard's place, he's on a double floor, so nobody could walk in front of it. So conclusions, the improved LEDs and lenses, you can get 12 dB. You could increase the size of the RX lens and possibly get another 16 dB. FST4 is perhaps 5 dB better than weak signal communicator, and is particularly important in a city area where you've got lots of lights and birdies. The 47mm 5-degree lenses are much easier to align than the 2.2 Fresnel lenses, and you can make up the difference just with a small increase in the numbers. My view is we should go for 730 to avoid public concerns. Distances of 500 kilometres are potentially possible with all these improvements. And that is it. If any questions?
Any questions? I've asked Brisbane for questions, so. They're all blown away.
Is there many operators that you know of? Is there quite a few operators around Australia that do this as well, or is it?
No.
There are 2.
That's it.
Both in this room.
The other bunch I know of are South Australia, who did quite a bit of experimentation out of what Rex was doing.
Yep.
But I don't know how active they are now.
Is that any?
That's Tim Dixon and
Yeah,
Clay.
but is that line of sight or?
Oh, it's line of sight.
Yeah.
Well, it's not,
I think.
not line of
I think over the horizon, we're the only group that's doing it.
Yeah. There was Chris VK3AML, who ended up becoming VK3AML. There was a de-expedition to Deal Island, and they did two-way contact between Deal Island and the Victorian mainland. Now, if you look on a map, Deal Island to the mainland, to the Australian mainland, is a whole lot less, and that was a line of sight.
Okay.
You can actually see line of sight those two places. Deal Island's off the top of Flinders. Keep going.
Oh.
Northwest of the top of Flinders. Yeah.
Correct.
Near the border, sort of.
Rex, just can you give a very basic overview? How are you encoding data into light?
Yeah. Basically, I get the output of WSJT on a computer, and that comes out as a sine wave. So I square that off, and I turn the LEDs on or off completely. Clearly, the result of turning something on and off as a square wave means I get harmonics up the band. Nobody's ever complained yet.
Don't need a low pass filter.
High absorption area of the atmosphere.
But you can see the harmonics, particularly the third harmonic and the fifth harmonic up the band.
Rex, when you're operating with Tricky in the summer and you get a sea breeze, do you notice a change in the propagation?
We haven't actually done this sort of testing in summer. We only started doing this test when the Brisbane VHF Group asked us to do a tour, and that was about 2 months ago.
Yeah, right.
So it's all been winter. But you're right that Andrew Cleverjack says that if you've got a breeze over the water, the salt particles should increase the aerosols. Yeah.
question from Brisbane, is it possible to pull the response of the avalanche diode to 730 nanometers?
No.
Okay, and the just
And they do make a different type of avalanche photodiode that works at infrared, but it's a much smaller area, and the area of the diode picks up far more energy because it's all in phase and it's all adding up together. And so you do need a very large area, and the only large area one that I have ever been aware of is the one that I've got.
Sure. The other question is, can you just go over the cooling of the LEDs again, whether you do need to do the cooling? Do you need cooling on the LEDs? You covered that a little bit earlier.
Yeah. I think the answer is you probably don't need a lot of like fan cooling. You do need a reasonably good heat sink. The reason I've put fans on is that I know that the efficiency of the LEDs depends on them being as cool as possible. Admittedly, at one stage back, Justin might remember, I actually put a what is the cooling device that you...
Peltier device.
The Peltier device behind the LED, and it made bugger all difference.
All it does is freeze the LED.
Yeah.
Condensation.
But
outside.
If you've got to have a heat sink anyway, putting a fan on it, well, you may not be doing much good, but I'm sure you're not doing any harm.
So it's more about efficiency than anything.
Yes.
What's an 1895
Heliograph?
Heliograph.
Okay, two mirrors with one mirror is keyed by a Morse key. You line up one mirror on the sun, which directs the beam to the other mirror, which is the angles vary just slightly with the keying. And you literally have a telescope looking at the other end, and you have the guy keying. And that record was done in Utah because they had heliograph stations. For those who don't know Utah, there are huge, very high mountains on both sides of where the Salt Lake City is, the basin, and they basically did a contact from one side to the other.
So it was a line of sight contact.
It was a line of sight.
Okay, yes. Yeah. I thought you said earlier it wasn't, right?
No, it was a line of sight.
Yeah. During the day.
Yeah, I mean, I think our 288 is still the longest non-line of sight.
and can I just say, Clint's done a record, and in fact I think that's the current line of sight record, using those mountains and those heliograph stations, which are all heritage listed now. They're just bunches of rocks. And he's actually done, he lives in Salt Lake, well, used to live in Salt Lake City, I don't know whether he still does. And he's done some line of sight contacts.
Yeah. That the heliograph was used throughout the American Civil War as a way of communicating.
The smoke signals.
Yes, well,
but it was more
I guess the Indian Wars, the Indians were using smoke signals.
And actually, if you want to see one, go to Anglesey Barracks Museum, the Army Museum, and in the radio room they've got a heliograph.
Okay. Oh, wow.
Which was used in the Boer War. That's why it's there.
And is the transmitter separate from the receiver?
No, they're exactly the same, and they they're.
So it's they key into
correct,
it, right? Okay.
Correct, and the receiver is a telescope to see the flashing light.
Yes, that was before binoculars.
Yeah. Now, any last questions for Rex? I've got none on here. Can we show our appreciation, please? Can I just do a reminder? Next week, it is not up here. It is at it's a visit to the Channel Men's Shed. So 24 Van Morey Road, Margate. So if you don't know, go through Margate to the other end of Margate. Van Morey Road is the big intersection, the sort of as you dive off down to Meritus Fruit Place. Van Morey Road, you'll see the big shed
To the right.
to the right next to the oval. From 6:30 there is sausage sizzle, so bring your please bring your coin. $2 sausage. Coin, remember cold hard cash. So that's next week, so it's not here, it's from 6:30 down there. And then we'll get a fantastic tour through the Channel Men Shed. So please come along. But fantastic. Thank you, Rex. And thank you to Brisbane. Thanks for being there. We have to get them to do a talk now.
Right.
And do it in reverse. Fantastic. Thank you very much. Grab a tea and coffee and have a look up close with the equipment. Cheers.
I might just